Hi, everybody. How are you? Goodish is good. Thanks. I'm good. Just hanging in there, you know? Okay, so we'll start in a few minutes. I posted an internship opportunity if you get a chance to check out the announcement, but I'll drop the link in the chat for you right now. This one, it's starting on in May to June. It's with Active Vision. If you want to check it out. It's a 12-week internship and it's geared for computer science and cybersecurity. I'll go into screen share so in case. So this one is in LA. It's with Active Vision. They want interns to test games. So starting late May or late June, you can do a 12-week internship with video game industry. And then you have to submit the application with your resume and your code sample. So don't forget, maybe if you have GitHub, you can link that. So in general, they want you to have knowledge in Python, PHP, JavaScript. I'm running a Python class. I'm teaching it 6 weeks, CIS 30A. It's articulated to transfer for UCR if you're interested to take it. I swapped out my 17A class. I'm sorry, Mr. Lee is teaching it. He's great, he's a developer. So, and I give him the rundown on what he needs to do in 17A to make sure that everybody's on the same page. But for this job, if you have JavaScript, Python knowledge, that's a plus. You're gonna work with web development, Linux administration, and Bash. So shell scripting is important. Also working with cryptography. We use that a lot for authentication, especially with web app. So knowing how to use cryptography, that's a plus. We'll talk about cryptography in this class for programming piece. So there are two parts to it. There's one that's global information security internship. Okay, and they want pretty much almost the same. This one has Windows, Solaris, and OS X knowledge, basic IT troubleshooting. And then the other one is the games information security internship. So you get to test game. This one you work with cloud database, scripting, JavaScript, and Python. So if you haven't learned Python, right, now is the time. It's commonly used in the industry. So RCC has a non-credit Python set, and then we have the credit ones with the certificate, 5 classes of Python. Okay. Do you have any questions before we? Yes.
I have a question about your Python class. Are you teaching that in spring or is it going on right now?
It's winter.
Oh, winter. Oh, that's awesome.
Yeah, it's purely online. I'm recording my lecture and you know, all my lectures gonna be code. That's what I do now in my Python classes. I either do live coding with them where I write it with idle and every assignment is most 90% of the assignment is all Python exercises. So coming away from CIS 30A, you should be able to get all the way from variable to object class, the whole work. So, and I'm using like a fairly cheap book. If you have Kindle, it's free. But if you want to buy it, it's like less than $30. I usually use cheap books, and I supplement a lot of stuff. You can learn Python strictly to reading their documentation. But yeah, so if you want, winter schedule should be opening soon. I just finished assigning everybody classes, so we're only running like a few, maybe like 6, 7 CIS sections. So yeah, if you want to take CIS 30A, you can. You can use that as a transfer credit for UCR because now they require that for computer science. And but if you want to pursue the certificate, there are 5 classes. 2 of the 5 classes are going to be for the cybersecurity majors. So it's Python scripting for cybersecurity, Python scripting for networking. So we work directly with automation with network devices and security appliances and stuff like that. And then 3 of the Python classes, the first one is a CIS 30A, which is a prerequisite for all of them. It does have some prerequisite. It has a CIS 1A prerequisite, but if you have taken other CIS classes, talk to your counselor. They'll email me and I will authorize it. But and then the other 2 Python classes is Advanced Python, which is data structure, and the other one is IoT Python, where you work with IoT emulator to write Python script for that. So it's pretty cool. All right, so check out the announcement for the internship. I hope you apply and get some experience. You also have option with apprenticeship, but now is the time to start looking for the summer. Okay. All right, so today we are going to do a little bit of a longer lab. I don't have too many questions, but we have 6 programs to do compared to 4 or 5 programs. You can find the lab in Unit 7 lab. The document is there. So let me get my file open here. Okay, so we are doing search and sort today. Okay. And so as we talked about it on Tuesday, we are looking at different type of search and sort algorithm. So I want to start with the most common search algorithm that you're going to find for computer science, right? Which is binary search. And at the top, it talks about how this is broken down. We talked about how if we have an array and if we're searching for a key, we would break down that array into half. And then we would also reduce it down to where we would be able to identify the key by narrowing it down to half and half. So the first part is that it has this array to start. That's your first iteration. Then we break it down into half. And what it does is that when you program this, you have to find a midpoint in the array. That middle value for the array to kind of cut your array into half. Then what you will do is you would use that value in the middle, we call that the middle, to determine if your key is higher or lower. Since we're seeking 23, 16 is lower than 23, so we will have to point it to the last half of our list, of our array. Sorry, I'm used to Python say list, of our array. Then when you point to this last half, then we can break it down into smaller halves and then be able to identify it. But in most of the algorithm that you will find is that it's going to use that, if we have a smaller array, we would use that last half and we would be able to do the comparison to find where that key would exist. Okay, so here it shows you the iteration for the binary. Our middle is going to be number 16. Since 23 is greater than 16, then we divide it into 2 halves. And then now we are going to look for 16 in the second half, the right side. Okay, so our half of the array would look like this. Now the middle point of that half, again, because we're cutting it down to half again, is 56. Okay, so 56 is the middle point. And then we would use an operator to compare. Is 23 smaller than 56? If it is, it's going to seek the left of that. If it's larger, then it's going to look at the right side. Okay, so again, in the second iteration, we are going to find a midpoint and we are going to compare. Then after that, the third iteration, it's now going to narrow down to only 2 as part of that array, 23 and 38. And the middle point now, since they're only 2, that will be 23, and then it's going to find the 23 there. So the procedure in this is that we want to find the middle value inside our array, and that's going to be our half point. From there, we can narrow down on which half, then we find a middle point again. Then we're going to narrow down on the smaller halves. Then we're going to find the middle point again, and then we're going to be able to identify our key. Okay, so it gives you the breakdown on how that's found. So lastly, as we discussed in the lecture, we found that the time complexity is log 2 of n, and you would use this to determine the comparison value that your program would go through with the input number, which is your n, or the number of elements in your array is n. Okay, so in the first example, this one is a binary search using iteration. And when we say iteration, automatically things that comes to your mind would be loop, right? Sometime we can write for loop, sometime we would use while, and then we would nest if or control statement to make sure that we get the proper output. So let's take a look closer on this program here. Let me get to my folder. Okay, so as you looked at the introduction to the binary search, in this one, we are going to implement a little bit of recursion, but we're still going to use iteration. Okay. So first, we have a function called binary search. Okay. And with this, our parameter is the array we call ARR. The L here stands for left, right? So we would have something that would represent the left side and something that represent the right side value. So the int R is the right. And then int X is your key. So all of these are going to be utilized in your function. Now we have the while loop. Left is less than or equal to right. We would declare that the middle is going to be left plus R minus 1 divided by 2. So we're going to section it, okay? And then to find the middle point, the half point, and we have to combine the left and the right side to get the entire list, of course. So I'm sorry, this is L, not 1. R, right minus left plus left divided by 2. Okay. Now here, we want to check to see if the key value is present in the middle. If it is, then it's just going to return. Okay. So we simply say that that middle value check to see if it is equal to our key. If it is, if that's true, then it's going to return the middle value. Okay. However, if it's greater, then ignore the left side because we want to go right. Remember that binary search algorithm, we want to have it pre-sorted. Okay. So it's simply a search. Okay. So you can implement a sort first, or you can just simply have it organized for ascending order. Then our else statement, if it's smaller, then ignore the right and look at the left. Okay, by doing the right is middle minus 1, which is just going to go to one value prior to the middle, and then it's going to start seeing there, which is the right. Okay, and then we have the return. So in the main, we assign our x value as 10. That's our key. That's what we're looking for. And we also have our array 2, 3, 4, 10, and 40. Our int n here is going to be the size of array, right, divided by the size of the first element of the array to really represent the length, right? So, and then what for our result, we're going to store, okay, we're going to call the binary search function. And then here in our parameter, we're going to use array 0, n minus 1, which tells us that it's a recursion, and then x. Okay. So in this, now when you write this, don't forget to include your header file. You need to have IOStream for C out. You need to have algorithm. You need to have array in order to have the size of to work. Okay, so those are the 3 things that you need to include at the top. So when I run this program, I will find that it tells me that the element is at index 3. And when we look, okay, 0, 1, 2, 3. Yeah, 10 is present there. Okay. So in the example 1, it uses, this is an iterative implementation for binary search. Okay. So you can input that into your IDE and run the program. And while you're doing that, I put down again the summary of the procedures. So we compare the x to the middle. That's the first if statement. Okay, if it matches, then return the mid value. Else, if it's greater, then it's going to go to the right subarray and seek the right half. Else, if it's x is smaller, if the key is smaller, it's going to seek the left half. Okay, so that's what's happening there. Any question? So we need to determine the number of comparisons of 5-element array using binary search. We know that T of n is log 2 of n. So when you plug 5 in for n, you can calculate that. You can either operate it like this, or you can have natural log of 5 divided by natural log of 2. You're going to get a little bit above 2 comparison. Okay. So we can round this off, right? If you round lower, you're actually not looking at the worst outcome, right? So we can predict that it's going to be between 2 to 3 a little bit above 2 for comparison value. Okay. So for part B, I put it in detail. You don't have to put it in verbatim. So this is what's happening. Explain the binary search processes given the array 2, 3, 4, 10, 40. Seeking the key is 10. Explain the functionality of the program and how the algorithm is implemented. So in the iteration 1, it divides the array into half, where 4 is the middle value, 2, 3 is on the left, and 10 and 40 is on the right. Then with the if statement, we compare 10 to 4. Since 10 is greater than 4, the right half will be used in iteration 2. And in iteration 2, divide 10 and 40 into half. 10 will be the middle. And it is evaluated to match key. Okay. So when you look at this, it's actually, if we go through the process, we can verify that it's about 2 comparison that the program gone through. Do you have any question?
Yeah, can you explain the first iteration again?
So the first iteration, you take this entire array and you cut it into half. 4 becomes the middle. Okay. So 2 and 3 is on the left, and 10 and 40 is on the right. So as you look at the program, okay, the first if statement here tells us to check 10 with 10, 40, 4 with 10. So your X is 10. So in the first iteration, it's gonna first divide your array into half. Okay. Then we are going to check the middle value, which is 4. Is it equal to 10? It's not, right? So 4 becomes the middle. 2 and 3 is on the left, and 10 and 40 is on the right. So when we compare, we evaluate 10 to 4, since 10 is larger than 4, it's going to go to the right side to search. Okay. And we would see that with this part. So it's going to use this one. Okay. Because 4 is less than X, your M is less than X, it's going to move 1 to the right of the 4, which is 10. Okay.
So then when it goes to the second iteration and 10 is considered the middle, it's because it's the, like, why is 10 considered the middle when there's about 2 of them?
Yeah, so the way they have it is it's the next value. So if you have it for 2, that 10 is automatically going to be the middle because there's no third value.
Oh, okay.
Yeah. So when you, and then what happens is literally you would have to cut that in half again. So the way we use it in the program is we say, oh, that's a variable. We're gonna use So when we cut this in half, if we have to push it into the next iteration, this gets cut in half again. So to save that step, what we say is, okay, so if we have 10 and 40, the left of it's going to become the middle, because that's going to be the first one to check. Okay, that's going to be the first value to compare as M. So when we use it as the middle, what will happen is we can evaluate it with the key first. If it's a match, it's going to return. If it's not a match, then it's going to go into the other half, the right, which is 40.
Thank you.
Yeah. Because if you look at the size of the subarray at that point also is it's 2, right? And if you divide it, you're gonna get 1 and 1 in parts. So what you have is you have to revert to that value on the left to check first, because if it's equal, then it's going to return. If it's greater than, it's going to move 1 to the right. And that was written in the program. Okay. Right here. And then the last part here, we simply just, right, we store in the result, we just call the function. And if the result is -1, then it's not in the array. If it is, then it's going to show. Any question? Some of you guys are great in C++. Go a long way. Good job. Okay. Okay, so that is part A and B of number 1. It's a simpler program to kind of look at and see, right? The whole point in this is to show you how it could be done. And of course, there's so many ways that we can write binary search. A lot of the times you see it, they would use tree to be able to implement binary search. But on a simpler scale, this is what we would see. So I want you to start looking at it from a simpler perspective, so that way you can understand the mechanism on how you would cut it in half and so forth. And then, if you learn data structure, you can definitely use different container, you can use pointer, you can use way for it to quickly seek and organize the value, and it can find it. What is the variable n in the main function for? So here, what does this part mean to you? Size of ARR. Doesn't that mean 5?
Yeah.
Yeah. Okay. What does this part mean to you?
It's the
Size of
size.
1, right?
It's 1.
Size of the first element, which is 1. So literally we're taking the 5 divided by 1. Why do we do that? Because with the array as a container in C++, right, it has to use some kind of equivalence. If it's not a dynamic array, you have to tell it to be like a constant value. So instead of specifying your array is 5 here, right? We initialize it, but with the int n here, we're saying that this n represent the number of the value because the size of the array is 5, and then we would divide it by the size of 1, the first element, which is 1. There's only one element, 0, right? Okay, so this int n really represent what, 5 divided by 1, which is 5. So it's another way to use a variable instead of specifying a constant variable. Okay. And then let me see. Yeah, that's the only time that you would, because the way that they have n minus 1 here is that when you go through the binary search, n minus 1 represents what? That value subtract 1, which is 4, right? 5 subtract 4. So when you're looking at the actual size like this, when it's going through and it's operating that function, your parameter is using the array. It's using 0, it's using n minus 1, it's passing x. And since that x take 1 place, you have 4 other elements that exist in that array that needs to be evaluated. Any other questions on number 1? Okay. So you're gonna see something similar in example 2. This is recursive. So it's similar to the first one. You're gonna see that it's close to the first one. And in this one, let me open it up and show you. We also have a function, right? We're still gonna, very much like the last one, we started with the midpoint, which is the middle. That's gonna be half of our array. We're gonna size that down to half. If it is equal to x, it's gonna return the middle, okay? And then what we want is if the middle of the array is greater than x, it's gonna go, if it's greater than x, then it's gonna return. So it would be smaller than mid, then we want to look at the left side. If it's greater than mid, else it's gonna go to the right side, okay? And we're using the same array and we're using the same key. So similarly, you're gonna see that this is almost exactly the same, okay? Now, when you run this, the recursion is implemented. How does it recur? Okay. This allows us to move back. So from that midpoint, if we need to go left, you will take that midpoint and you move one element over. That's going to be a subtract 1. Okay. Now, if we wanted to move 1 to the right, then we would do a +1. So if it's greater than that middle value, we want to go right, mid +1. And that's going to bring us to the right side so that way we can evaluate X. Okay. Then, yeah, so it's about the same. I think in the next semester, I'll just have them do one or the other. But you can get a little bit of practice. You don't have to put in all the comments, so the program's much shorter. So if you're looking at the procedure that I gave you right here, it tells you the actual mechanism that's, you know, all the parts in that iteration. So compare X to the middle value. If it matches the middle, return the middle value. Okay. Else, if it's greater than the middle value, then we're going to move to the right by 1 place. Okay, after the mid element. So we recur right to the right half. Okay. Else, if it's smaller, then we're going to recur to the left. So if you need to explain this, right, you can explain how that if statement is gonna evaluate the middle value to determine, and then if it's not matching the middle value, then it's going to recur right or recur left. Right if it's greater and left if it's smaller. Compare example 2 to example 1. Which program is more efficient? Explain your answer. So this one, if you look, it has nested if, right? For example 2. And in example 1, you have a while with if else. Okay. So example 1 is more iterative. And example 2 is more recursive. So like we talked about before in the last couple of labs, we talk about how we would trade space for time, right? And so in the case of recursion, think about how you would use a larger array. Is that more efficient? Okay, I'm talking about like maybe 1,000 numbers or more, because it would eventually reach its limit. So in my opinion, I think iteration for us is a little bit more efficient compared to recursion, because you have some trade-off in that. Okay. And yeah, they're pretty close. The main difference is that in the first one you have a while loop. Okay. And when we run number 2, it's still going to give us the same. Any question on 2?
Hi, Professor.
Yes.
I just finished typing the second example, but I find out after I run it, I find out it says element is not present in every.
So I think maybe you miss an if statement. If it's not present, it's returning -1. So it might have not checked true. So check your first if condition there. Make sure this is L, not 1.
Oh yeah, I mistyped something.
Okay,
Thank you.
yeah. That's easy to track. You know why? Because if it's return 1 here, that gotta be the first if statement that check false. So, you know, and the way the IDE is, it lines up all the indentation for you, so you can quickly troubleshoot. Mhm.
Thank you.
You're welcome. Yeah, so we should get element is in index 3 as it finds 10. Now in other classes, right, like more advanced programming classes, they would have you write binary search tree. Okay. And you often see more of those programs. If you look for examples for binary search, you would often see binary search tree, BST. Any question on 2? The L here, the way we use this is to represent left, Carlos. So it's just a variable here. At this point, we're saying left plus right minus left divided by 2 is the middle. Because you have the left portion and then you take the right portion, subtract the left, you're given, and then divided by 2, you get a middle value. Okay. And then over here, because we use it to represent the value to the left of the middle, that's what L is. Okay. Other questions on number 2? Okay, so you saw 2 approaches for writing binary search. The third part is on the jump search, which is what in our lecture we talk about this as chunk search. So what we can do is we can group them by dividing it up instead of half and half, right? We can divide it up into chunks. And in jump search, when it narrows down the chunk, it does do the linear search backwards. Okay. So as we talk about this in the lecture, we know that the chunk size would be square root of n, and n is your input, the number of elements that you have in your container, your array, vector, or some form of container. So in the program, what you have is you have this array, okay? And what you're doing is you are going to seek the value 55 in that array for the jump search. So what we know is that there are 16 elements in that array. And when we take the square root of 16, we know that it needs to jump 4 every time. We're going to section it to 4, 4, and 4. So the first jump, it's going to go from the index 0 to index 4. So we go 0, 1, 2, 3, 4. I can't highlight it in multiple colors, so forgive me if it looks kind of funny, right? So it's actually getting to 3 here. Okay, so I'll do that right now so you can see. Okay. So 0, 1, 2, 3, 4. That will be the first chunk. Then the second chunk would be represented from index 4 to index 8. So 4, 5, 6, 7, 8. So it's going to go all the way to 20, 21 here. Okay. Then in step 3, the jump will be from 8 through 12. Okay. Now, since the element at index 12 is greater than 55, so when we're looking at 8 through 12, it is 144. It's going to go back 1 and it's going to check that again. And it's going to go back 1 and it's going to find 55. So once you get to that last jump, what it will do is going to say, is that the maximum value in this sub array for the jump, the chunk, is it higher or lower? If it's higher, it's going to move left. Okay. So we're going to do a linear search backwards inside that last chunk. Okay. So it gives, this is the procedure that it gives you here. Okay. So let's take a look at the program. Okay, so here's our program. We have the function called jump search. We're using the array. X is going to be our key, and then N is going to represent the number of our input. We need to chunk it, so we would have square root of N. So that way we can take 16 elements and we can find out how that's going to break down into chunks. Okay, and that's going to be stored into step. So that's how it's going to jump. So here we initialize prev at 0. And so while array, so if we're going to check for the min, okay, and we're going to move 1 if it's less than X. So in this right here, it's gonna help us find, this entire block's gonna help us find if X is present in certain chunk. So as it iterates through, it's gonna go from one chunk to the next chunk. This is why you have the compound operator right here, right? We're gonna move from jump 1 and then jump 2 and then jump 3 and so forth. That's why we have it in a loop. Okay. Then this section of the code allows us to identify or to do the linear search once we get to the chunk that would contain the key value. So here we're using a while loop, right? If X is larger than it, then it's going to increment. If ref is min step n, it's going to return 1. So when we reach the end of that block, when we get into the next block, then that means that the element is not there. Okay. So we would continue to loop that. Now, if it's found, we're going to return it. And in the main, we declare our array. We assign a value to our array. We declare our int x as the key. We assign a value to for that to seek. Here is your n, which is 16. Okay. And then when we use index here, index is gonna call the function, right? And it's gonna pass array x and n. So because we want to, I'm sorry, go ahead.
Is there a reason why we don't have the array sorted?
Yeah, I guess you can have it sorted, but whether it's sorted or not, we can just, because you, in this one, you find a min and a max already in each chunk, so it doesn't really matter. You see what I mean? So when I
Okay.
chunk it, like if I chunk the first 4 right here, right? It's gonna say, oh, what's the minimum? What's the maximum? Now, if you have it pre-sorted, you can simply use indices to kind of put a marker.
Okay, I see. Understand.
Okay, yeah. So the reason why that we have to have the int index here, right, is because we want to find out where that key is, because that way we can call the function and it's gonna operate, right? And it's gonna tell us which index that would be in, which is gonna give us index 10. Yeah, so Albert asked a good question. This one is not sorted because we break it into subgroup, and then in each group we find a min and a max for that anyway. So, and you can find that up here. Okay. There's min. Okay, so now when we look at the chunk, determine the chunk size given your array, which has 16 elements. So you simply take square root of 16, which give you 4 each. That gives you the jump size or the chunk size. The comparison that you would see, it's estimated to be 8. So we would take 2 times square root of n, that will give us 8. And when you look at the steps that we talked about, the procedure earlier, you're gonna see it's about 8. So compare this one to the binary search. Binary search is definitely more efficient, right? When you look at the way that we can either use recursion or even on the iteration, we calculate it to be about a little bit above 2 comparison, and in the jump search you're at, for this one, even on the higher, well, the input size is important as well. So when we're looking at like a size 16 array, elements array, well, you would see that it's about 8. So for part C, it says explain how the functionality and how the algorithm is implemented. You can give the breakdown on sub part of the code, or you can also refer to this to kind of get a bigger picture of how that was searched, the key was searched. Okay, so look at page 4 or review through your code and you can explain that for part C. And the search objective for this goal is very common for a lot of application, right? But outside of database, outside of, you know, when you see everything that we use now, we search from OS level to web to everything that will be some kind of keyword search or value search. So, and consider how you organize your data or structure your data. That's also important. So at more of the elementary level, we would use an array like this. Any question on 3? So when I was rewriting this lab, because, you know, I wanted to kind of screen out some of the things that weren't working in the last couple semester, I was debating whether to implement quicksort. I remember when I was teaching C++ 17A, we wrote quicksort program. Okay. And so what I wanted was to kind of introduce you to a shorter program to start, for example, for using STL. Okay. So in this, it says that sort, when you're using the member function sort, it is a mixture of different algorithm. The majority of the times you're going to see it operates very much like a quicksort. which is a fairly efficient, right? You have n log n for quick sort. And sometime it would also change to heap sort and insertion sort. Okay. So in the sort, what it does is it use addresses. So in the case where if you pass variable in the back, the compiler is just going to look at the start address and the end address, right? To be able, so the first element of the array, and then for the end address, that will be the next contiguous location of the last element of the array. And with the sort function in the STL, it rearranges the element in the address range. Okay. So this is a quick short program to kind of show you. We don't have any special function that's defined. We just use it directly in main. You have an array. It has these elements. And we want to sort them. So we want to rearrange them in order, ascending order. Okay. So here is our sort. And then you want to start with the array. And then you want to do the array plus n. Remember that it uses addresses. So we can have it output, and this is just for output, the for loop. So it accesses the value and then it shows you in order. Okay. So when we run this, it would reorganize. It organizes the value from low to high. So you get 0 through 9, which gives you 10 elements. Okay. So once you have the program created and run, you run the program in IDE, take a screen capture. And for part B, it says explain the sort functionality of the program, how the values compared for order arrangement. So really in how we assign the values here, right? What the compiler, what it does is it's really taking the addresses and it's rearranging the address. And so when you access the address, it's gonna, when you have this for loop right here, you're just accessing the address of each of the element in order. So when you have it output, it's in ascending order. Okay, so it's really rearranging the address of the values. Okay. Do you have any question? Okay, no question on number 4. That one is an easy one. So you can use a built-in member function from STL, but then there will be, sometime you have a class that they require you to write sort algorithm, then you have to write sort algorithm. Okay. All right, with the selection sort, we talk about this as in how it's find the minimum element of the unsorted, and then it's putting it at the beginning, like how you would use cart. So the algorithm, it would use 2 parts of the array. The sub array is going to be sorted, that's at the beginning, and then the remaining array that's unsorted. So it's going to organize the first in the first half, and then the last half of the array remains unorganized, and it needs to go through and reorganize it. Okay. So every iteration of this, we are going to look at the minimum element, because we want to use ascending order from low to high from the unsorted part of the array, and we're going to move it over to the sorted, which is the beginning. So we wanted to set up the array where the first half is the sorted, and we're going to slowly move, right, each of the element into based on its order. Okay. So when you have something like this, if your array is 64, 25, 12, 22, and 11, what we want to do is we want to take the minimum value, which is 11, and we want to put it in the front, the first half of the array. Okay. So we're going to take the 11, we're going to put it to the front. Then we're going to take the 12, and we're going to move it to the 11, after the 11, and then so forth. Okay. So as you can see, right, we gradually would have a sorted array, but the first part of the array is going to be sorted. The last half is not. Now, when you do the movement, I mentioned that you need to have a swap. We got to have some kind of variable or some location where we can place that value temporarily, right? We wanted to do a triangular move. Otherwise, it won't work. So when you move the 11, you have to take the 11, right? Put it in the temp, move the 64 over, and then move the 11 over. So we have to do some kind of swap. Okay. And that's what you see in the program. Okay, so let's take a look at number 5, program. So we mentioned that we would need to have some kind of swap functionality. So here is the swap. And we're not returning anything there, so we're using void. And in this one, you're using pointer, correct? Okay. So when you define such function, you have to also, if you're using pointer for the function, you have to make sure that you have that specified. Okay. So all we're doing is we're going to point to the position of X and Y. Okay. So XP is really the pointer for X, and YP is the pointer for Y. And then we're going to place that on temp. Here is our selection sort function. So with this, we need to determine the minimum value. Okay. So we would use a for loop here. We start at element 0. Your I is going to be min IDX. So what this will do is we have to find the minimum element in the unsorted array. What's the lowest value? So we would nest the if inside the for loop here. Okay. Now, as we have the void swap defined earlier, or you have the function header there, what you have here is we would have to actually swap it. And here they use a reference. Okay. To reference the minimum value or the minimum index and the index. Then in our next function, this is simply just to print it for cout. In our main, we declare and assign our array. We call selection sort. And then we have it cout the sorted array. We call the print array. Easy. Okay. So there you have it. You have 11 moved to the first place, and then 12, 22, 25, and 64. Any question? Okay, so we would run our program, take a screen capture, and for part A, explain the implementation of selection sort algorithm in the program. How are the elements evaluated to rearrange the values from lowest to highest? And when you go through before the program, it explains all the steps for you there. Okay. And you can also look at each section of the code. So refer to page 6 and 7 for part A. And the program uses the nested for loop. So you would have T of n is equal to n squared. And so you would have approximately, with the way it has to reorganize, it's gonna go through and it's evaluated 25 times. So 5 to the second is gonna give you 25. Worst case scenario. So how do I know it's a nested for loop? Your main function that does the sort is this one. Right? You have a nested for loop here. On the outside, it needs to move one by one for the unsorted. On the inside, we need to check for the minimum element. Okay, the other functions are just for swapping and printing. So we don't, the main mechanism lies in the selection sort. Any question? Okay. We still have a lot of time, so I don't want to rush you or anything. If you have any questions. So important takeaway from this before we move on to the next one, right? These type of program, you need to have some kind of swap, okay? So usually we would implement a function for that. And then often you would see that pointers are used. Okay. So on the last one, you have merge sort. And quick sort and merge sort has the same time complexity. So in the merge sort, the best way to really describe it is through the picture there. Okay. It's divide and conquer. It takes the array and it divides it into half, divide it into half, divide it into half again. And when it gets to the lowest halves, it's gonna sort the lowest half and then merge. And then merge. Okay, so we talk about merge sort in the lecture. So you take this array, you cut it into halves, then you take the half, you cut it into half again, right? And you take it into and you divide it until it gets to the single element. Then when you merge it back, it needs to be order. So 27 goes before 38, the 3 goes before 43, the 9 goes before 82, and the 10. Then we merge it at the next level. As we merge, we will have to, it needs to organize. So the 3 goes before the 27, 38 goes before 43, And then on this side, 9, 10, 82. Okay. And then lastly, we merge the two halves together to get back to the original array size, but now it is sorted. So I copy and paste this, so you can copy and paste this into your IDE, but be careful with the symbols. Sometime from Microsoft Word bringing it into your IDE, it might not read the curly brace or quotation marks or parentheses. So if it throws an error, check your syntax. Okay, so at the top, we have the merge function. And in this one, we're using L for left, M for middle, and R for right. Okay. So your int N1 here is the middle minus left plus 1. Your int N2 here is right minus middle. So this is a way that we can start seeing, like just like the binary search one, we have to cut it in the middle. So we have to we have to find what that middle is, right? And what would represent the right side of the middle and the left side of the middle. Then we have to have temporary arrays. And this is, I feel like this is a better approach than using the variable to swap things out, because you have to cut it into so many sub array. Then you should use a temporary array to be able to store things back. Okay. Then here is our for loops. The L and 1, that's going to be for the left side. We talk about the left side as the sorted. And then the R and 1 is for the right, R and 2 is for the right side. Okay. So this allows us to put the data into temporary arrays. Now you can have it as a separate function. You just gotta call it. But the way that they created this, it's already built in with the merge. So as it merges, it's gonna copy the value. So with the while loop, so here it tells you which index is which. I is for the first sub, J is for the second sub, and then the K is for the merge. Okay. And here it would check. So it says that if the index, which is the index for the first subarray, if it's less than N1 and a J is less than N2, then we would build in the nested if here. If left is less than right, then we're gonna have the array for the merge. That's gonna be the left. Okay. Else, that's gonna be the right. Okay, and it will continue to copy so we can have it for the left and then for the merge array, copy the remaining right. So with the void merge sort, this is the one that's gonna give you after it. So the first part is where we need to break it into half, right? And then we gotta copy the left and then the right. Now from this part on, what we're gonna do is we're gonna merge the left and the right together. So here is that we would check if left is less than right, right? Like you've seen this before. We've seen this in the binary search one. Okay. Then we would have the middle would be, so that way we can find that middle value. And then we call on the merge sort. So this is going to give us the first half. This is the second half. Okay. And then the last function here before the main is your print. So it's going to display. So we simply use a for loop with that to access each of the index. And then in the main, you have your assignment of array. This is your array size. And you would call on the print. You could call on the merge sort. And then you call on the print. So this first one is just the original array. This one is for the sorted array. Okay. So here it gives you the procedures. So for question 6 asks you to run the program, take a screen capture. For merge sort, we know that T of n is n log n. Then your T of n is 6 log 6. Let me double check. 7, I'm sorry. There's 7 elements. So for part B, we need to explain how the merge sort algorithm is implemented in the program. You can go to the code itself and look at the different section of your code, or you can also refer to page 11. This is like the pseudocode part of it. Okay, so we find the middle point to divide the array into halves. Then we would implement the functions to section it where it would be the first half is the sorted. The second half is the non-sorted. In this one, they use a way to copy that to temporary array. Once you have it copied, then you would merge the two halves. Okay, then you call the merge. I like C++ that for such that it's very clear the way the statement is, but it is lengthy. In in the for loop you have 3 parts, and Python is a lot shorter. So you can do 3 lines and 1 line in Python. So and they have a lot of built-in. Any question? Okay. So since we do 6 program, I only have a couple questions for each of the exercise. So make sure you answer those questions, provide the screen capture, save your document, and then upload it for assignment grading. Okay. And then if you missed the beginning, check out this opportunity. Activision is a pretty cool company to work for. So, and I dropped you can find this on announcement or you can find it in chat. Okay. Okay. If you're finished, you can put in your name in the chat. I'll stick around for questions. Make sure that we submit the assignment before Saturday or by Saturday. And I hope you have a wonderful weekend. If you want to take Python, sign up for CIS 30A in winter. 6 weeks, short and sweet. It's a fun class. You're going to do all kinds of program that's business related. So solve fun problems. Okay, I will see you on Tuesday next week. And next week, we're going to go over relations. We will likely have a quiz review assignment for homework. Okay, we have an upcoming quiz. All right. So chapter 11 next week. Sequence, sums, and series. Have a good one, everybody. I'll be around if you need help. You're welcome. Good night. Does anyone have any questions? Good night, Albert. Check your grade, Albert. You need to upload that document for me again, but look at it. I put a comment for you. Okay. Okay. Good night. If we can cite you for NCA's recommendation thing. What what is NCAS? Abraham, what is that? I'm new, so sometimes I don't know all of these acronyms.
So essentially, the NCAS is a whatchamacallit? It's a NASA internship, and they want a recommendation letter from at least one professor.
Oh, okay. Yeah, so shoot me an email.
Mhm.
That way I can draft something for you and then let me know on the email when you need it. I prefer to give me like a day or two on
Mhm.
it. Sometime I can whip it up on the fly, but
Mhm.
you know, I want to put some thoughts into it.
Definitely.
Yeah, so better if you want any form of letter recommendation, stuff like that. Sometime they would require that they send a link when you add my email address and then I fill it out with them. That's okay too.
Yeah,
But yeah, so if you do it that way, it's fine. Is that who is that through? You said the NCAS is to who?
Through who I don't really know actually. Like the main website like goes to like the Oklahoma State University, but I received an email I think 2 days ago. It's like, oh hey, come to this workshop.
Oh, okay. So it's geared for aerospace engineering. I see. Yeah, that's why I'm like, I don't know of this, but yeah, so NASA has the community college aerospace collar.
Hmm.
Yeah, so one of my former student is still working at JPL. Yeah, if you can get an opportunity with them, that's a plus. So sure. Yeah, you can put my name down or my email down, and then if they send me a link, I'll fill it out. But if you want a letter, then just shoot me an email and let me know when you need it by. So definitely.
Yes, because I want to get into something either electrical engineering or cybersecurity. But well, I know.
So you can do both actually. There's a lot of well, there's a huge area that's lacking in IoT assessment, and you have in IoT you have to know how to use electrical boards.
Mhm.
You have to work with circuits and things like that. Um, a good way to kind of see, I know InfoSec does some stuff like they do training and they hire people and they do a lot of testing with that. So, but what do you see yourself doing? Do you see yourself like developing systems, working with like, because electrical engineering, um, I mean, there are a lot of jobs opportunity for that too. Also in cybersecurity, it's a different animal. So not that only you have to know, you know, how electronics works, but you also have to know like all the other aspect like networking, programming, which you're learning now. Um, but if you like electronics, yeah, there are great opportunity for that too. I have family members who are electrical engineers and they did well, or they're retired now, but they don't work anymore. However, you
Yes,
know.
because off the top of my mind, either like building routers and switches, like on a hardware level,
Oh,
possibly, or that sort of stuff. But so like
you can
the
go into computer engineering too.
yeah,
Network appliances, low level programming, you will find a lot of that. Like if you like assembly, uh, which is CIS 11, you know, because that is more close to like gates and, you know, stuff like
well,
that.
I
So
mean, I do plan to take assembly,
CIS 11.
yeah, in spring.
Yeah, I teach that. I teach it in sometime. Last one I teach was LC3. I'm started to look at ARM now, but I'm afraid that like if it because ARM has different versions. A lot of the time, people don't know that they, you know, even and Microsoft is even harder to work with because the library for the Microsoft sometimes is, you know, it's difficult. But yeah, so what, see how you like that class, because architecture, if you can understand it and you can be, that's really important in, you know, computer engineering, electrical engineering, computer science, because ultimately computing is, you know, it's circuits. So good for you. So yeah, shoot me an email if you need the, I teach Arduino and Raspberry Pi sometimes for the kids, and I wrote non-credit courses, so I like to tinker with circuits and circuit boards and stuff like that too. So yeah, I have breadboards I build and such. So yeah.
But on the internship for Activision and like the other ones you've posted, I don't have any practical experience, but I want to like um, join one. So how do I get experience if I don't have any experience?
Let's see what it wants. So it says must pursue a bachelor degree, either have computer science degree or similar preferred. Passionate about learning, candidates must apply with a resume. So that's the requirement, the profile. Now for the cybersecurity side, I think they, on the top, they want like, if you participate in competitions. I thought I read that somewhere. So what you can do is you can, the on the programming side, I know RCC run the the ACM, which is like coding competition in November, or the end of this month is when they start. The cybersecurity side, it hasn't started yet, but you can look at National Cyber League. They are opening the gym now and you can participate. And even if you have like very little knowledge in cybersecurity, I say you should attempt it. It's about $25 to participate. It's a great practice because in the gym, if you know, if you're trying to solve something, if you don't know how, it has solution, or it tells you where to go and what to do and what to look at. So I had some of my beginning students did it and they really enjoyed it. So that way you can say that you did it, you know. So I would recommend that. And then you can participate in some hackathon. I think Makerspace or I Make Innovation Center at Moreno Valley College, they're running some Python, you know, intro level hackathon things like competition. So you can once I have the flyer, I'll share with you guys. So you need to add those things to your resume and that will give you the leverage as interns. Okay. What else? If you want to practice as far as programming goes on HackerRank, that one is a good one to use. Okay. And yeah, so apprenticeship, try signing up for apprenticeship, look for a different type of internship, but everybody starts somewhere, you know that, so they know. Okay.
Okay. Well, bye.
Bye, take care. Eric, do you have any questions?